late in the day, but very exciting panel here in the Panda Hub. I told my daughter, who's 6, who's very into pandas, that I was coming here to the Panda Hub, and I set some unrealistic expectations about how many pandas would be here. Perhaps I'll take a picture of the picture and I'll pass it to her. I'm Bridget Hoyer-Gosling. I lead Google.org's work to leverage advanced technology for some of our biggest social challenges. Google.org is Google's philanthropic arm, and at Google, we are really committed to thinking about all the ways that we can use the tools that we have, our products, and our own operations to really think about driving more climate action and creating a more sustainable future for all of us. It is probably not a surprise that we're pretty excited about AI these days, as are many folks. And we are especially excited about harnessing the potential of AI to supercharge our work on climate. We think that this is not just something that is a future potential, but really something that we're already starting to see, and really can be a tool for us to really accelerate innovation that will help us to get there faster. I want to be clear, and I always like to be clear, that AI is not a silver bullet. It is not magic pixie dust. It will actually not solve all of our problems, but it is a really powerful tool and increasingly becoming even more powerful with more dynamic models that we can use for many different purposes that we don't even know yet. And we'll continue to see that work evolve. And it's most powerful, actually, when we can really put it in the hands of folks who are deeply able to build that work, those models in context, and implement work in their expertise to deliver on real action from the insights that we can get from those models. And we're already seeing a lot of applications across adaptation and mitigation, and everything from monitoring and measuring biodiversity loss and emissions to predicting natural disasters and being able to provide information to people to act on those earlier. And then I'm excited also about the ways that we're starting to see AI really aid in scientific research. Just this week, Google DeepMind, which is one of our AI labs within Google, announced a new model that's actually putting out tens of thousands of new material types, crystals in this case, which we don't know yet what folks can do with them, but they're providing them to scientists to think about ways that we might be able to see new battery types or other critical materials. And these are the types of things that we can do with AI that we wouldn't otherwise be possible. Obviously, this is not work that Google can do alone. It's not work that any of us can do alone. And so I am really excited at Google.org that we've been working over the past 5 years to support organizations who are using AI in their work to supercharge their efforts. And as I said, it's critical that these kinds of solutions are developed in partnership by people who have that expertise, which is why I am delighted today to say that we have convened senior leaders from, I think, a true who's who of organizations working on the sustainability to really talk about the role of AI in this critical moment on climate. In addition to being leaders in all of their fields, each of the organizations was recently selected through our Google Impact Challenge on climate innovation. We selected 6 projects from around the world that we thought were really meaningful in terms of their ability to potentially change the trajectory of the issues that they were working on using AI and data. And 4 of those you will have the privilege to hear about today. So with that, I will move to this other chair. Get started. Thank you, magical mic person. All right, so as I said, one of the most interesting things about the work that you all are doing with AI is really that all of you have long histories of working in sustainability and climate, coming from established organizations who really are leading the way in this work. And it is, I think, the case that we were really intentional about keeping the call that we did around AI really broad, because we know that there's a lot of different possible ways in which we can see AI applied that we can't predict from the outset. And it really comes, I think, when we see scientists and experts and folks who really deeply understand the problem and start to get that spark of an idea for where AI can be most useful. So I would love to just have you all introduce yourselves briefly, and then also, most importantly, talk about a little bit more about how your organization is addressing the climate crisis in applying AI to do so. And we'll start with you, Marcine.
Hello, can you hear me? Okay, great. Hello, everybody. My name is Marcine Mitchell, and I'm the Senior Vice President for Climate Change for the World Wildlife Fund. And as a conservation organization, we address climate in many, many different ways, around energy, around we are very committed to using nature-based solutions as a way of addressing climate change. And that's where we apply AI. It is so important because nature is a huge carbon sink for us. It is a way of pulling carbon out of the atmosphere through our trees and our oceans. Over 52% of the carbon that we put up in the air is actually absorbed by our oceans and our land. And so it's important that we maintain and expand nature for this important solution to climate change. Oh, sorry. So sorry. But we as conservationists often don't know what the impact of climate change will be on nature over the long term. And we've seen just even recently on the wildfires in eastern Canada or in the Amazon, how hotter, drier conditions can turn a nature sink into emissions. And so it's very important that we learn how to adapt to these new climate and temperatures, and that's where AI comes in. So thank you very, very much for this innovation grant. It's so important to do this type of work. We have a project that we're working in Mexico called Manglaria, which means AI for mangroves in Spanish. And what we're doing there is in these protected areas in Mexico, mangroves provide lots of services. They're the super nature for climate. They not only do they absorb carbon even much more than tropical forests, they also protect against storm surges. They are, provide nurseries for fishes and crabs and things of that sort. So they really are such an important resource. And with this project, we're looking about how the change in climate will impact mangroves so that we can make sure that we're supporting them. Using weather stations, using satellite imagery, using other type of sensors, drones, we're able to therefore get data that we couldn't get otherwise, or certainly not in the time period. They can tell us about temperature and rainfall and salinity and pH balances in the water, all the things that impact mangroves and their survival. And we can use this huge database, right? We can collect all this data and then bring in AI to help us get insights into what areas should we be restoring, what type of mangroves are resistant, really being able to put our money well to use and really learn in terms of how we can best protect and grow and expand these mangroves. So this is really absolutely key type of information for us to go forward and to use it for the communities in terms of their livelihoods, their access to information, and their ability to keep these vital resources alive and well and expanding in their areas.
Yeah, I think one of the interesting things, you touched on this briefly too with mangroves, is that, because they are also a tool for climate adaptation, right? We can see that disasters, things like hurricanes, are mitigated by their presence. Actually, also studying that coastline gives us this really interesting information on resilience too. And I think, using these kinds of data for multiple purposes is something that's really meaningful, and that an organization like WWF is able to kind of take in all those different directions. Janet?
Great, yeah, thank you very much. And thanks, Bridget and Marcin, for the opportunity to join today. I'm Janet Ranganathan, the Managing Director for Strategy, Learning and Results at the World Resources Institute. So WRI has about a decade of history of experimenting and using AI for climate and for many other issues that we work on. So our work right now is very much focused on driving systemic change in 3 systems that are actually critical, not only to climate goals, but also nature and the world's people goals. But they are the food linked to land and water system, the energy system, and the urban system. So there are AI applications for climate mitigation and adaptation across those 3 areas. We're probably most known for the work that we've done on mapping forests using AI, and thanks to the Google Earth Engine, a great partnership, University of Maryland and many others, we actually were able to use AI to map forest cover change today at near real-time 10-meter resolution across the planet. Thanks very much to Google Earth Engine there for that thing. We've gone beyond mapping deforestation to actually looking at how trees come back. We are involved in a number of restoration initiatives globally, Africa 100, Latin America 20 by 20. So looking at trees come back, again using AI with that methodology, then expanding that to all land uses. So a very innovative data set, Dynamic World, which was again developed with the Google partnership, which actually maps a 10-meter resolution, all land cover and land cover change. All of these products are open source, open code, open methodologies, open APIs. I wanted to talk about one specifically, which is our expansion now into actually using satellites and actually ground data to monitor heat, the effect of heat in cities. So cities are typically 5 degrees Celsius higher than any of the surrounding areas. So heat islands is a big problem. We know about 500,000 people die every year from that. The actual number is probably a lot more. So how do we actually, first of all, how do we work with urban planners to do something about this? And one of the first things they're going to tell you is, we know it's a problem, but we don't know how to act on it because we don't have data. We don't have usable data at the resolution that we need it. So how do we actually identify where the problems are? So that's using satellite imagery, but it's also combining it with ground data. So using AI to help us with that. Actually developing scenarios of how that's going to change going forward. We use AI for that across the life cycle. And then turning that information into actual insights and combining it with information on urban infrastructure. So that 5 degrees higher is also impacted not just by the climate impacts, but also the design of infrastructure. So how much reflective surface do you have, solar reflective surface? Trees, roof gardens, permeable surfaces, all of those things can mitigate this. So looking at those two things together, we can identify particular heat spots and actually identify also opportunities to take specific actions by increasing reflective surface, increasing the inclusion of trees, and creating more shade to actually do something about it. So that's one of our specific examples, and it's supported. Thank you very much from a Google Innovation grant. I'll stop there.
Thanks so much, Janet. Wayne?
Good evening, everyone, and thank you so much for this opportunity. Thank you all for coming. I'm Wayne Walker. I am Chief Scientific Officer and Senior Scientist at Woodwell Climate Research Center. And at Woodwell Climate, we're focused on science for solutions at the nexus of climate, people, and nature. And we're really focused on the solutions that we feel are needed to really propel us toward a more sustainable, more equitable, more healthy world. We were founded in 1985 as the Woods Hole Research Center. Many of you might know us better by that name. And we're a relatively small organization compared to the organizations represented by some of my colleagues here on the stage. We're about 120 total globally, and so as a result, partnerships are super important to our work. We very much operate under a partnership model, and where partnerships are concerned, we're talking about everything from national governments to corporate entities to NGOs, like some of the folks here, to indigenous organizations. In terms of our science, we're also focused on nature-based solutions across 5 programmatic areas. 2 are geographically focused, tropics and Arctic. The other 3 are topical, water, carbon, and climate risk. And we really bring what we feel is those sort of a comprehensive toolkit to bear on our science. We like to say that we've got eyes in the sky and feet in the field. We bring together field data, laboratory data, remotely sensed data with computer algorithms, including and increasingly artificial intelligence tools, to really understand the interplay between human activity and natural systems with the potential to really impact the trajectory of our climate future. I think our Google.org funded project is really an excellent example of the sort of work that we try to do. The goal of this particular project is to track permafrost thaw during the snow-free season across the Arctic, and really take the pulse of what's happening in terms of Arctic permafrost thaw. Now, why is this important? Well, first of all, as many of you know, Arctic permafrost contains tremendous amounts of carbon. And when that permafrost thaws, obviously that carbon can end up back into the atmosphere, having a significant impact on climate change. Currently, that carbon in that permafrost is not well, the rate at which it's thawing is not as well understood as it could be. It's not captured well in current climate models, and so it's super important from a climate change, from a climate system standpoint, that we understand that better. But also, as it happens, there's 3.3 million people that are living on permafrost that between now and 2050 is likely to thaw. And so those folks are quite vulnerable to that potential thawing. This particular project is led by one of our scientists, Anna Liljedahl, who's based in Alaska, based in the Arctic. And AI really is playing a critical role in this project in three different ways. First of all, it's about automated feature detection and mapping. So there's all sorts of features out there in the landscape that can serve as proxies for permafrost thaws. Unfortunately, I don't have time to get sort of into the weeds here, but we're talking about things like ice-rich polygons, ice wedges, slumping ground that occurs after the permafrost thaws, okay? Changes in lake area, changes in water levels, all of these things can be mapped, particularly with the increasing availability of high-resolution data. With those features mapped, again, with the help of AI, we want to look at trends. In particular, we want to look at the correlations between where the permafrost is thawing and environmental variables to understand why it's thawing, where it's thawing. And then with that information, we can use AI further to do seasonal forecasting, all right? And this is super important. Again, thinking back to the 3.3 million people living in the permafrost region, these folks would like to have an idea, first of all, where the vulnerabilities exist, which communities might be most vulnerable over the near term. And for the communities that are likely to be most vulnerable, those communities need to be thinking about potential resettlement. And with the sort of data sets that we're producing, we can think not only about planning and forecasting, but we can think about the best locations for those potential resettlements to occur. So we see this project as really providing sort of an early warning system focused on planning and then ultimately, potential resettlement. As part of the project, we're developing a permafrost discovery gateway, which is a web-based platform where all of this data will be housed to provide in sort of an interactive and very accessible way information to communities, to decision makers, to scientists, such that it can be used in sort of all the ways that I've talked about. And we're very fortunate also as part of this project, where the AI piece is concerned, to have a group of Google fellows that are working with us on the AI piece, on development of the permafrost gateway, and on a number of different topics associated with the project. So we're most appreciative to have this opportunity, and I'll stop there.
Thanks so much, Wayne. I love all these projects, but I do feel like this is kind of the first picture that we'll have of permafrost, and it's pretty remarkable that we've been missing it for so long. So really excited to see what will come. Jonathan, want to round us out?
Sure. I'm Jonathan Banks. I'm the global director for the methane team at the Clean Air Task Force, which is also a relatively small organization, about 180 folks scattered around the world. We work on climate and energy issues in a variety of different ways, but our methane work has been going on since the first science around methane emerged in a study in the year 2000. I've been with the organization for 23 years and working on methane since the beginning. We work on a lot of different issues around methane, trying to mitigate methane from the oil and gas sector, the waste sector, ag, as well as the coal mining sector. I'm going to talk mostly about our work with the waste sector. We are in a project with RMI that is funded by the Global Methane Hub and Google.org to create a better stream of data for the waste sector. There's really, really poor data on the waste sector, not just on their emissions, but on what's going into landfills so that you can figure out how to mitigate the methane emissions that comes from those landfills. The program's called Waste Map, and it's just been launched earlier today. We have an integrated program online that allows us to collect data from multiple sources, satellites, on-the-ground data, studies, et cetera. The work is also coupled with what we call country engagements or deep dives, where we're working directly with national governments and municipal governments to help them overcome the barriers they have to mitigating methane emissions in their waste sector. But one of the big problems where we're tasking AI is that, believe it or not, landfills and dump sites are not well known as far as where they actually are. And while we have all these great new satellites and aerial measurements that can measure emissions and figure out, okay, how much methane's coming off a landfill, we actually don't have a very good map of where landfills are around the world. And so we're using AI as a way to map the sites all around the world. Dump sites are a lot harder to identify because they don't have as common of a resolution as the landfills do. But we're using AI to really dig through high resolution data that allows us to create a better map of these sources. And then there's all these methane satellites that are now up in the air and more going up. We use the data that's generated from AI to then target those methane satellites to those sites so that we create a circle of ever improving data. There's a bunch of satellite companies and organizations that are running around here. You'll run into them if you go to methane events like I do. Carbon Mapper and EDF and GHGSat are some of them that are running around. But they can't do and bring the data that they can to bear if they don't have targets for their satellites. And so that's the big space that we're using AI in this instance. Another space that we're looking at using AI is to use AI to digest large volumes of documents and create searchable data sets for communities and create essentially a chatbot that allows communities to be able to ask questions where AI has harvested all the best data from the studies that exist out there. So that's essentially some of the work that we're doing around the waste sector using AI, but there's a bunch of other places that I think we can talk about as well.
Thanks so much, Jonathan. Yeah, I mean, I think that the projects that you all just talked through really highlight, the variety of ways that we can think about this technology being used, right? We talked about measurement and monitoring and observation. We talked about getting better real-time information. We often, think we have data, and we do, but it's usually often coming maybe months, years after the fact, and that does not allow us to act at the urgency that we need to act today. Talked about scenarios and modeling, right, both in the waste sector, but also for the extreme heat work. And really a lot of pattern recognition, right, that's happening in that wouldn't be possible just at the planetary scale that we need to be doing it, and at the scale and speed that we need to be doing it. So I'd love to take the rest of our time to kind of just dig into what makes these projects work, how do we think about grappling with the use of AI in this space in an effective way, with a hope that folks listening can come away with just a better understanding. Janet, you talked about, right, at WRI, you all obviously have been doing this type of work for many years, for over a decade. I would love to just know, what have you learned from that work that you feel like is relevant? What do you feel like really works, and where would you sort of direct people who are thinking about kind of taking some of these new tools on?
Thank you. Yeah, so just to caveat that we're still on a very steep learning curve and still learning.
We all are, including me when I sit at Google, so.
A few things. I mean, that's the importance, particularly us up here that are in the world of sort of NGO world, nonprofit world, of keeping everything open. open source, open data, open training data, open methodology, open science, open APIs. Why? Because it gets more eyes on it. Therefore, it improves quality. It creates trust and credibility. And then most importantly, it actually leads to scale because other people can build on your products and have their own impact. So actually just enabling impact. And sometimes I have to tell you that the things that have been built on WRI's things have actually maybe even been more impactful. So, think very broad about it. So everything open. Second thing, very important. It's like, when you're buying a house, you have to think of three things, location, location, location. With designing data tools for impact, it's like, it's user-centric, user-centric, user-centric. It's like you have to start with the audience. Like, what's the problem? Who's going to help you fix this? What information do they need? What information do they already have? How do they get the information? Why would they be motivated to use it? Testing the apps with the user, rolling out the apps with the user. It's really kind of key. I'm just thinking about GFW Pro, Global Forest Watch Pro, a specialized app to help companies that have made deforestation-free supply chain commitments to actually identify where the deforestation is in their supply chain. So, just creating a coalition of companies, first of all, that actually had this problem. Okay, we made the commitment, but we don't actually know how to now monitor our supply chains. But working with them to develop the tool, having them sort of roll it out for us, like they stand up there and give the testimonials around how it's useful, much more effective than if WRI were to do it. So the user thing. The third thing I want to say is, the science is really important, getting the science right. So we don't allow any kind of data product to be published at WRI without a peer-reviewed methodology, either in a journal or through a WRI publication process, which is peer-reviewed too, out there. Just this sort of open methods. That's really important to the trust. Also want to say it's increasingly important for us to get beyond how many users are using it to actual impact. So a good example of this is Global Forest Watch. So it has developed a GLAD alert with actually the Google Earth engine helps us with this, and the University of Maryland. But it provides alerts to subscribers, which actually is an issue with open data, is that you don't know who's using it, but there is a subscription service. So we know who's getting the alerts. And we actually looked at deforestation. We don't want to just say, oh, there's X number of people receiving the alerts, that's our success. We actually looked to see if these alerts had any impact on deforestation, using our own data in this particular case. And we found that actually in Central Africa, the use of alerts was actually correlated with an 18% reduction in deforestation, which is about 50,000 hectares there. This was published in the Proceedings of the National Academy. But then when we looked in South America, same alert system, didn't have any impact. So trying to understand, why we've got the users there, but there's no impact. We have the users here, there's no impact. So it's really important for us to go from use to ultimately impact. So that's the second thing I would talk about. And then just sort of the evolution of our work at WRI. Our pockets of excellence in AI was scattered across WRI in these small projects. And we found it hard to retain good staff with expertise because they were often like the lone technical person in a largely non-sort of expert team. So they just felt like, and they were often, they were like supervised by someone who didn't have the same skills. So we created a centralized data lab, not because we wanted to take the innovation away from the programs, but really to sort of create a hub of institutional excellence. So all of our data experts, they sit in the programs, but they also have a homeroom called the Data Lab. And the Data Lab's been really important in creating that homeroom, but also now building out common data infrastructure. Because what was happening at WRI is we'd go, each project, they didn't have the full range of specialists, so they'd go out to vendors who are spending a lot of money on third parties. And we were often, creating the same digital infrastructure with the same vendor in another part of WRI. So that would be a third thing. And then I just think the challenge of sustainable funding for these works. So if you want to be open, which we are, you're not going to be able to charge. You have to think about how do you develop these apps that are sustainable. And the best advice I can have is, collaborate and create partnerships. I mean, if you can integrate these apps into other funded things that are ongoing, whether it's with governments or other organizations, that's one way to deal with this. But it is a challenge, and it's I don't know if there's any funders in the room, but there is this temptation of funders to, they're always after the next shiny object. I always feel like we just got to this point of 5 years of funding, we're just about to have big impact, and now you're not doing that, you're moving on to something else. So it is a problem. So maybe I'll just stop there. Thank you.
I think you just gave us maybe a 201 course, Janet, and a lot of the things that we see and learn from the projects that we work with, so really appreciate that. I think, I mean, you touched on this partnerships point, right? And Wayne, you mentioned this too, right? That partnerships are so important to Woodwell's approach in getting your work done. I'm curious, just how do you think about the difference in partnerships for AI? How is AI helping you to build collaborations or, to explore partnerships that might have not been possible or weren't maybe part of what Woodwell was doing prior to this?
Right, well, partnerships are absolutely critical. As I said, we're a very small organization, 120 people. Total, roughly half of those are scientific staff. We don't have deep expertise in AI and these advanced technologies. We have some individuals who are strong, but to pull off the sort of project, for example, that we're talking about in the Arctic here with permafrost, we obviously need expertise well beyond what we have in-house. And in a field that is growing as fast as it is, evolving as fast as it is, I think it's hard for any sort of organization, big or small, really, to sort of keep up. And as a result, this is a great example. This particular project, this Google.org funded project, is a great example. There's 8 different institutions involved, many of them universities. And almost all of them are bringing some level of AI expertise to bear on this project. Obviously, Google itself, particularly through the Google Fellows, are bringing AI expertise. And these are all organizations, or at least many of them, I think, that perhaps we would not be partnering with if it were not for AI, and certainly if it were not for this project. So I think in this case, and I think certainly moving forward, AI presents a really big opportunity for us to sort of expand our reach, particularly in terms of partnerships, which, as Janet mentioned, are super important. I mean, not just for our organization in terms of impact, but for all sorts of other reasons as well. So.
And Jonathan, you talked a little bit too, just about, I want to pick up on Janet's point too, around just that action from the insights, which is a problem that we had before AI when we just had data too, right? And now we just have more data, hopefully in more places, and it still has the same challenge of how do we make sure that once we have it, we can actually do something with that. I feel like you all are doing some really great work with that on the waste map, and would love to just, hear your thoughts on what you feel like is really most effective there.
Yeah, I mean, I think I said this earlier today. I mean, data doesn't lead to emission reductions. It has to be tied to something else on the ground that brings about the policy change and the actions that lead to emission reductions. And whether you're talking about mangroves or deforestation or permafrost or methane, it's different things for all of that. But one of the things that we're doing is marrying all of the data work that we're doing to the in-country work. There's no separation between the two, and it's a circular cycle of the in-country work is feeding new and better data back into the database that we're collecting to increase people's understanding and ability to tackle the problem. We start with engagements either at the national level or the municipal level. We start them essentially with sessions to sit down and talk with the community members that are around the landfill about the problems that they're facing with their waste. This isn't about methane when you're talking about this. This is about like a circular economy of issues associated with waste. In a lot of the places we're working, they're in very different stages depending on which community you're working in of how to manage waste. The problem is the answer is a holistic answer, and we're focused on the methane issue, but we're tackling the problem through a holistic approach. And I think it's just critical always to marry the data issue to something that is actionable. I think another place where we are exploring AI is in the satellites that are going up right now. The satellites are already there. You see it in the news all the time. They're catching what they call super emitters, these big giant plumes of methane, either coming off of landfills or oil and gas sites or whatever. And it makes for great news stories, but it doesn't mean that that data is getting to the right people to actually go out and fix the leak in the pipeline. We have instances where that has happened, but it's really, believe it or not, complex to do that. You sit there and you go, okay, is it this pipeline, or is it this processing facility over here, or is it this? It can be really a jumbled mess when you're looking at the satellite to figure out where it's actually coming from. Once you've identified that, then you got to figure out who owns the darn thing. And that can be really difficult depending on what country you're talking about. Then you got to figure out, okay, who in that country is responsible for administering the regulations and can actually call these guys up and get them to go out and fix it. It's a really complex thing, but there's a future of AI where you can imagine a multimodal AI system that can harvest the emissions data, that can scan local regulations and company data reports and things like that, that can be able to connect the data almost immediately back out to the regulators that have the ability and the companies that have the ability to reduce those emissions in a much quicker fashion. Right now, that process, when we see a big emission source on a satellite, first, it takes about a month to get the data out because it's all being done by hand. That can also be fixed by AI. But when we see one of those big sources, it then takes months and months sometimes to get to the point where somebody actually goes out there and fixes the darn hole in the pipeline. And I think AI has the capability of actually trimming that down in the future to almost nothing. So that's a ways out because we don't have that capability at all right now. But it's definitely something that we're looking at as a way to really accelerate mitigation in this space.
Yeah, and those months obviously really matter when we're talking about methane and the potency that it has for all of us. Jonathan, you mentioned this, the work that you all do also around the waste sites, right? The communities and going to work with them. And Marcine, I know that you also talked about that with the work with mangroves, right? Obviously a huge part of the ecosystem services that they provide to the world, but also to the communities. Do you talk just a little bit more about how is the work that you're doing really fostering partnerships? How are you building collaborations with stakeholders and communities to really make sure that the outputs of this work really work for them?
Right, great, thank you. And I think everyone has talked a little bit about, going from the technology to impact, right? And for WWF, because we're working in these areas, communities are so important, and we really need to put communities at the heart of the work that we're doing. If there's this disconnect between the technology and the community doesn't feel the buy-in of the technology, then it really can't be sustainable over the long term, right? We have to be aware of not just kind of flying in, coming up with this great technological solution, having more information about climate change, and then flying out with our great technology and not benefiting the communities themselves. One, the communities won't invest in the solutions that we need to do, and if they don't feel like they have access to it or they don't feel like they have ownership with it, then, again, it won't be sustainable. So in this Minglaria project, we really work to put the communities and to make them feel ownership of this. We do training for communities so they're part of putting in the sensors, getting the data, collecting it. We make sure that there are local benefits as well as global climate benefits. So if we're using weather stations, can those weather stations be used for early warning detection? If we're looking at surface temperature, can that help the fishermen determine, this is a good time to fish or where they should be fishing? It's really important that people feel like they have that technology is accessible. I mean, even in our own lives, right? If things are really great, but we can't, access it, we don't understand, or we can't use the data, then it is not useful to us, and we won't maintain it. And so that's really what we try to do: bridge this issue of technology with community benefits, so that at the long term we're really improving people's lives as well as improving the lives of nature, improving our fight against climate change.
Yeah, absolutely. And I think that you've actually all touched on, right, the ways in which we need to be connecting these often large-scale seeming numbers to the ground, and so critical. We know that's true, and also really hard. So maybe AI can help us with that too at some point. We're going to leave a little time for questions. If you have them, start thinking about what they might be. But before we do that, I'll maybe throw just a question to whoever would want to answer, which is, I think we've talked about, a couple people have mentioned this sort of rapid pace of the technical development here, the desire, especially the need for NGOs to try to keep up. Janet, you talked about just kind of the challenge of that, even for an organization who has the experience that you have. And also, we're in the moment where we're trying to tackle this challenge that we have on climate with great urgency. So I'm curious just for your thoughts on what gaps and opportunities do we sort of have to try to make action more quickly. What would you ask of us as a technology company? What would you ask of kind of government or others to really sort of be able to meet this kind of AI potential for climate?
I can just say very quickly in the conservation area, and I think I led with this too, we're very good at what we do and what we know, right? This monster called climate change, we're not, haven't been prepared for it in terms of the long-term impacts. And so, the technology and the AI helps us accelerate the actions that we need to do. It helps us become educated. We actually need to take an exponential step change. I mean, fighting climate change cannot be incremental. It has to be an exponential change. We have to accelerate at an exponential rate. And, to do that, you really need the technology can really help that, can really help us. You were talking about how, again, you guys do very much what you do very well, but bringing in this new kind of skill set, this new type of technology that can help exponentially accelerate the things that you do well. So that's how I would say for, these NGOs, for other organizations, even research organizations, bringing in the best is what's going to help us really work at the speed that we need. This is an urgent issue, and so working at the speed and the capacity and the scale, and to replicate. I think that's it. We can also take these data sets, we can also take these insights, and we can apply them much more quickly to other places. So that's how we can replicate, that's how we can scale.
Just building off that, I mean, I would say that's exactly right. I can't tell you how many times these days we're having conversations around, for example, just big data. Like, we have the ideas, we know where we want to go, but it's the computing power, or it's the if we could just come up with this algorithm, like we have the idea for it, but how can we get it coded up? I mean, it's those sorts of challenges, but also those sorts of opportunities. And now I think we're in an increasingly just really exciting place. To make some headway on those sorts of issues. And so from a research point of view, in terms of accelerating our impact, I think it's a really exciting time.
Janet?
I guess I'd also like us to maybe think about slowing down in some cases. I think we have to be careful. We should treat AI as experimental. We just come out with some internal guidelines at WRI to make sure that we're being responsible. They're quite simple, but making sure that we always put a human in between the results, that we're not using AI where we don't actually have the domain expertise that we need to have. Being again very transparent about our methodologies, being very careful not to introduce, particularly with the large language models, anything that's proprietary, any kind of confidential data. It's easy to do that, even partnership data. So just sort of slowing down a bit. With our data products, like our traditional knowledge products, you produce a knowledge product and you're kind of done. You might come back and do a second edition in 2 years. But with our data products and methodologies, like version 1.0, version 1.2.3, it's sort of like iterate and learn and update the methodology really fast. So that's one thing we've been trying to do. I've noticed that where we've been pushed by funders to do things more quickly, like we have something called Energy Access Explorer, which is actually trying to figure out how to get energy to the 700 million people that don't have access to modern energy. So It's a methodology. It basically looks where there's potential demand, where there's capability to pay for that demand, but it's not there right now. So it uses a number of methodologies, but this community engagement thing's really key. And if you don't build the time in for the community engagement, you're not going to get a good result. So again, that takes time that often we're being pushed to sort of cut. So I'll just say, be careful on the speed.
And can I just add one thing to that? So again, in this project that we're working on, we also use the community to reality test the information. So we can also get too caught up with how perfect our technology is, and it's really important that those who are actually got ears and eyes and knowledge, who've lived in a place, for example, for years and know things, can reality test what the data sets, what the AI is telling us. So that kind of builds back to that community engagement piece, and that kind of a little bit go slow to go fast, that we can't get too caught up without at least having kind of eyes and ears on the ground and using those human minds, using that traditional wisdom that we really have a lot of and that we sometimes don't pay attention to, right? And we know that, especially in climate, we know that we've lost a lot of traditional wisdom that could have saved us a lot of pain when you think about some of the wildfires and how those have been dealt with in the past. This is the same type of thing that it's a good to reality test with those who know.
Let me just sort of say that there are things that AI can speed up, like some of this repetitive stuff that takes us ages, it should be. But yeah, there are other things where we're deploying it, building the partnerships and the foundational stuff that we should be going carefully.
Did you want to say, you've been holding the mic, Jonathan, just want to make sure.
Sorry. I'm not going to tell Janet that I used ChatGPT to write my talking points today, but
Use Google Bard, right? That's what I heard?
Yeah, that's
Yeah.
what I said.
It's okay, I probably did too.
No, I think, especially, in the environmental community, we are not AI specialists by any means whatsoever. Even when, we have some experience in using it and deploying it, I do think that we're in a very extreme early stage of us even exploring, how and where and when to use it. And I think that I do think that Google can play a role in helping to convene and create the space for thought processes around that and a place for people to share their thoughts and ideas and how they're addressing these problems. I think there's a real space for community learning even within the environmental community. And I think that's an opportunity that you all could play a leadership role in, because we're all kind of sitting around in our own little spaces going, we got to figure out what to do with AI, and people are thinking about this in these, silos, and we should all be working together and working with people who are actually AI experts to help us think, okay, how could we use this in a better way?
I'm really glad that we got to both of these points, right? The going slow and the sort of responsible deployment. We've been talking a lot in this particular moment where, frankly, I think we're all feeling that urgency around AI about being bold and responsible. How are we bold in the intention that we set and the sort of potential we see? And obviously in the same breath, right, being responsible about what we do and acknowledging that AI isn't good at everything, many things it's actually quite bad at, and that can be a distraction, right? And I think I worry sometimes we're all, maybe taking up too much airspace when we have other things that we could spend time on. So how do we, to your point, Jonathan, be sort of more precise about where it can be useful and help sort of build that capacity? Okay, I think we have time for maybe one-ish question, if there are any from the audience, and if not, no one, okay. I'm not good at quiet, so I can leave a slightly longer pause if anyone's itching to jump in. Okay. With that, I'm going to close us. I think that we, have one of the things that I think is so evident from the projects that you're all taking on is that this experimentation is happening in really profound and meaningful ways, right? These are not just, small projects that you've taken on. These are taking on some of the more complex issues of our time: methane, permafrost, extreme heat, mangrove tracking. These are hugely important resources that we have on our planet and need to be conscious of, thoughtful about, that really affect communities, that will affect our climate change trajectory. And really, one, just so honored to have the chance to partner with you all and the tremendous organizations that you're a part of. But two, I think to this last point, right, helping us to really hone the places and show the way on where and how AI can be really impactful, and where it can't, right, and really being honest about that. So we will all look forward to following the progress of these projects as well as others, and join me in thanking our panelists for sharing their thoughts tonight.